The basic concept of toxicology is the dose makes the poison. As dose increases, so does the risk of adverse health effects. When we represent this graphically, it's called the dose-response curve. We graph dose on the x-axis, so increasing dose from the bottom to the top, and on the y-axis, we graph the increased number of adverse health effects. The curve may start out very low and flat, but as dose increases, certainly adverse health effects and the percent of response will increase as well. There are several factors that affect dose. One of these is intake. How much of a chemical are you exposed to, and how much of it do you take into the body? The type of exposure is also important. Are you exposed by ingestion, by inhalation, or by dermal absorption? Different chemicals enter the body in different ways. Another important factor is time. How long are you exposed? Is a person exposed to a small amount of a chemical over a long period of time? That would be an example of a teacher in a classroom, for example. Or are you exposed to a large amount of a substance in a short period of time? That could be an acute accident, for example, in a laboratory, or a large spill of a chemical within a community. The denominator of the dose equation is body mass. Two persons could be exposed in the same way, have the same intake, and for the same period of time, and yet have different doses. The reason for this is body mass. A larger person, like myself, is going to have a larger number in the denominator than a smaller person with a smaller body mass. Although we might have the same route and magnitude of exposure for the same period of time, I would have a smaller dose than the smaller individual because my denominator, my body mass, is larger. So from a public health perspective, and as we try to make the classroom safer, as we try to make the laboratory safer for teachers and for students, there are several things we can do to reduce dose. Number one, we can reduce the exposure level. Number two, we can reduce the time of exposure. And although you can't really do this very well on an easy basis, the smaller the body mass, the greater the dose. Since you really can't change your body mass so much, we want to focus on the exposure level and time of exposure. I mentioned earlier the routes of exposure: ingestion, inhalation, and dermal exposure. Inhalation is going to be things like vapors or gases with which you may work in the classroom or in the laboratory. Dermal absorption, the skin is a very good barrier to many chemicals. Yet some chemicals, like benzene and other solvents, penetrate the skin very well. Pesticides, for example, penetrate the skin very well. And so we need to be aware of the routes of exposure, which could be problematic. Many teachers don't think about ingesting chemicals. They think, well, how in the world do I ingest something? When you actually breathe in, for instance, particulate matter, and it gets caught in the mucous membranes, it may be expelled through the nose, but if you actually swallow mucus, you're ingesting that material. That's called incidental ingestion. Many people don't think about that at all. You may actually get a chemical on your hand, not really thinking about it, and then due to hand-to-mouth activity, incidentally ingest that chemical. That's another form of ingestion and another way to which you can be exposed to a substance in the classroom or the laboratory. There are many ways to look at how hazardous or how particularly toxic a chemical is. And one of those that's used quite often is what's called the LD50 or the ED50 of the chemical. The LD50 stands for lethal dose 50%. And what that is in a laboratory experiment, controlled laboratory experiment, with laboratory animals, typically mice or rats, what is the dose that will kill 50% of those laboratory animals? In other words, as you graph dose versus percent response, and percent response in this case is death, what dose kills 50% of the subjects in the study? The graph shows that we have percent response and we have dose. When you get to 50% response, you can then draw across the line and hit the dose response curve, drop down, and that is the LD50. Dose is expressed in milligrams per kilogram per day. Milligrams of the substance per kilogram of body weight per day of exposure. Another effective way to look and compare at the toxicity or the hazard of chemicals is what's called the ED50. Since death is not the endpoint we're really trying to protect against most often, we're trying to protect against any type of adverse health effect. And so ED50 stands for effective dose, 50% of the subjects. For example, what dose would cause 50% of a group of people to begin to suffer headaches or to experience dizziness? Certainly we want to protect against those health effects. That provides an entire cushion for protecting against lethal doses. So the effective dose 50% is actually what we really want to protect against in the laboratory and in the classroom. Now there are different regulatory agencies or different advisory agencies that set standards for exposure in the workplace. The one that has enforcement authority is called OSHA, the Occupational Safety and Health Administration. They establish what are called permissible exposure limits. These are the levels to which an employee could be exposed 8 hours a day, 5 days a week, for 50 weeks out of a year, and would not be expected to experience adverse health effects. Exceeding a PEL, a permissible exposure limit, within a workplace is something that can result in enforcement action by OSHA. Another group that has advisory authority is called the National Institute for Occupational Safety and Health. They are a sister agency to OSHA. They conduct research for OSHA, but they do not have enforcement authority. So their standards, or their guidelines would be a more appropriate term, that they establish are exactly that. They are guidelines, and they are not enforceable. Another group, called the American Conference of Governmental Industrial Hygienists, establishes something called threshold limit values. Again, these are advisory only, but are good guidelines when you're trying to establish safe levels of exposure within the workplace.